We'll now go through some diseases that are caused by dysfunctional amino acid metabolism. We'll start off with phenylketonuria here, or PKU. It's going to be one of the most common enzyme deficiencies, with an incidence of about 1 of every 10,000 people. Since it's so common and so important to detect, the USMLE will love to test on PKU. So make sure you know the mechanism of action and the amino acids involved for this disease on test day. Now, what are the causes of PKU? Pay attention. Like I said, this will show up on test day most likely. So what are the causes of PKU? Now, it can either be caused by an autosomal recessive deficiency of the enzyme phenylalanine hydroxylase, which is used to convert our phenylalanine to a tyrosine. Or it can be used or caused by tetrahydrobiopterin deficiency, which is a cofactor for this process to occur. So either one of these can cause this reaction to not occur, so you'll get an excess buildup of phenylalanine, but you'll also get a resulting decrease in tyrosine levels. Now, the excess of phenylalanine can be converted to phenylketones such as phenylacetate, phenylactate, and phenylpyruvate. Now, these phenylketones get spilled into the urine, hence the clever name Phenylketonuria. Tyrosine, thus, becomes an essential amino acid since our phenylalanine doesn't get converted into our tyrosine. And if it isn't consumed in the diet, the catecholamines thus cannot be produced. Because remember, tyrosine then goes off to produce our catecholamines, our CATs for short, such as our norepinephrine, our epinephrine, and dopamine. So remember, if we have phenylketonuria, we need to have tyrosine within our diet. It's an essential amino acid now because we can't synthesize it. Now, thinking back to our discussion about catecholamine synthesis, phenylalanine was converted to tyrosine, which can then be converted into our catecholamines. Also, without tyrosine, you can't produce thyroxine or melanin. Consequently, patients with PKU will have intellectual disability, growth retardation due to the lack of thyroxine, seizures, fair skin due to our lack of melanin. They may present with eczema and a musty body odor. I want to highlight this, remember this, which is caused by the excess of phenylketones. Now, to remember this connection, keep in mind that the phenyl functional group is an aromatic ring, and patients will thus have a distinct aroma. If you see the words musty body odor on test day, immediately think of phenylketonuria. Now, if a patient is diagnosed with phenylketonuria, how will you treat this disorder? The treatment of PKU is to eat less phenylalanine. It makes sense, but you also need to have more tyrosine in the diet. Since artificial sweeteners such as aspartame and NutraSweet contain phenylalanine, patients with PKU should avoid these. Now, if you have a pop can in front of you, I want you to do a little experiment for me. I want you to check out the label. So turn it over, check out the label. Most diet pop cans will say something along the lines of, phenylketonurics contains phenylalanine. It's going to be a little warning label. PKU is going to limit your intake of Diet Coke. So that's a little aside that this is common, and pop can companies, especially diet pop can companies, do have the warning because it contains phenylalanine. All right. PKU can also arise in the fetus if the mother does not have a sufficient dietary intake of aromatic amino acids. Infants from these mothers can have microcephaly, intellectual disability, growth retardation, and also congenital heart defects. You'll see the same congenital defects if the mother has PKU and doesn't adhere to her dietary restrictions, since phenylalanine and its phenylketones can then thus cross the placenta. So newborns are often screened for this disease 2 to 3 days after birth. We got a flash quiz now. A 3-day-old infant has elevated urine phenylacetate, phenylactate, and phenylpyruvate. what are the two possible defects that can cause these findings? This question is going to be asking what defects cause phenylketones to accumulate. The first defect could be due to a missing enzyme, which was our phenylalanine hydroxylase. However, remember that this reaction also requires the cofactor tetrahydrobiopterin. So if you have a deficiency of that, it can also occur. So if either of these two are missing, phenylalanine is not able to be converted to tyrosine or its derivatives. Alkaptonuria, which is also called achromatosis since it causes cartilage damage, is another defect in that amino acid metabolism. So we talked about PKU, now let's talk about another. Here's the larger picture. Now, I don't want you to memorize this. Let me repeat, I don't want you to memorize this. I do want you to take away that here's our phenylalanine that we were talking about. Here's our tyrosine. We saw this pathway. However, now we're going to take a little bit of a detour through a whole bunch of steps here, and we're going to create a fumarate. Now, let me get rid of all this because I don't want you to memorize it. Let's focus on what you should know. Now, here we see the enzyme homogentistic acid oxidase. Now, it's going to convert our homogentistic acid, which, if you can remember here, is right here, and we're going to create our malacetoacetic acid. Now, Alkaptonuria is simply a deficient homogentistic acid oxidase enzyme, so it's going to be missing or not working, blocking this reaction. This impairs the degradation of this homogentistic acid, and thus we're going to have a decreased fumarate level, but we're going to more likely get an increased homogentistic acid buildup. Now, what is a major buzzword for Alkaptonuria? The major characteristic finding is that your urine is going to turn black on standing. Now, this gives it the nickname black urine disease. So Alkaptonuria, if you have a patient pee in a cup, let that urine sit out for a while, it's going to turn black. It's going to really scare the tar out of you because of this homogentistic acid buildup. So, let's take a look at some of the symptoms. We already said black urine. Other manifestations include dark connective tissue, brown pigmented sclera, and debilitating arthralgias. Now, this is because you have a buildup of the homogentistic acid and is toxic to cartilage. Therefore, if you see black urine or black tissue on test day, I want you to think Alkaptonuria or a homogentistic acid buildup. Moving on, we can now talk about homocystinuria. Now, homocystinuria literally means the excess of homocysteine within the urine. That's just breaking down its name. Alright, so this is a disease that exhibits locus heterogeneity, since there are many genetic causes that produce the same phenotype. It has three main causes: a cystathione synthase deficiency, a decreased affinity of cystathione synthase for pyridoxal phosphate, which is going to be the active form of vitamin B6, or you'll have a homocysteine methyltransferase deficiency. So now let's break this disease down further. Treatment of this disease depends on the cause. Cysteine is made from cystathionine, which in turn is made from homocysteine with the help of cystathionine. So we see the pathway here with the different important steps circled. So, since the excessive homocysteine will be converted to methionine, this is going to consume a lot of vitamin B12 and folate. Therefore, a treatment of cystathionine synthase deficiency here is going to be increase your intake of cysteine, B12, and folate, and then decrease your methionine intake. In the case of decreased affinity of cystathionine synthase for B6, so here's our B6, if we have decreased affinity, it's going to be best treated by just simply increasing your dietary intake of B6 and cysteine. If you have decreased affinity, you want to flood your B6 so that way it can be used as a cofactor for this reaction still. And then lastly, in the last case, if homocysteine methyltransferase is deficient, so if this enzyme is deficient, methionine becomes essential in the diet. All right, so the treatment is going to be increased methionine within the diet. Regardless of the etiology, how do patients with homocystinuria present? Patients can typically present with intellectual disability, osteoporosis, a very tall stature, kyphosis, subluxation of the lens, and thromboses, atherosclerosis. Here's an example of subluxation of the lens in a dog. Not sure if you've seen this before, but this is what it would look like. Cystinuria is going to be a rare autosomal recessive defect. So, autosomal recessive defect of the proximal convoluted tubule in the kidney, and also intestinal reabsorption of some basic amino acids. Now, these will include cysteine, ornithine, lysine, and arginine. All right, to remember these amino acids, you can use the memory aid COLA. I even like to take this one step further and think of Coca-Cola, where the first and last letter in cystinuria are C and A, so cystinuria, therefore Coca-Cola. All right, cystinuria is the Coca-Cola disease. The defect in cystinuria ultimately leads to the excretion of these 4 amino acids here into the urine. One of the more important effects of this disease is that cysteine can precipitate and form kidney stones, which are also called cysteine staghorn calculi. What is the difference between cysteine with an EI and cysteine with just an I? So, cysteine versus cysteine. All right. Well, let's break this down a little bit. The cysteine with an EI is an amino acid, where the one with just an I here is going to be a dimer of these two this amino acid, which are going to be connected by a disulfide bond. Now, patients with cysteine kidney stones may have hexagonal-shaped crystals in urinalysis. That's going to be an important thing to remember. The urinary cyanide nitroprusside test is diagnostic for cystinuria. To treat cystinuria, patients can be given acetazolamide or citrate to alkalize the urine. Alkalizing the urine is going to help cleave the disulfide bond into cysteine to form 2 cysteine amino acid molecules. It's also important to drink lots of water and also stay hydrated in this disease.